Hi. In this short tutorial, we're going to learn to create a custom function, which can be very useful in making our spreadsheets effective and keeping them well organized. Further, we'll also name the variable areas so that the function calls are decipherable when we look at them in the formula bar. So I've opened up a spreadsheet that asks us to program a custom function to represent the bilinear curve of the resistance function shown in the diagram. This is a great example to use because one of the strengths of custom functions is used when defining multi-domain functions. The first thing we're going to do is to name the cells that contain our key variables. So let me just show you the spreadsheet here just for a second. So we have the statement of the problem. We have our key variables. In this case, we have the ultimate resistance RU, also shown on the graph, but given a definition numerically in cell E18. And then right below it, we have the other key parameter, which is the value x sub e, which is the deflection, if you will, at the end of the elastic region when it goes into plasticity. And we also have a variable for x max, but it's not going to come into it. It would actually be used to test against later on. Down below, I've just set ourselves up. So really what we want to achieve in this is that we want to use our custom function to fill in this region in here based on the different values of deflection in the column before it, shown right there. So we're going to do that. So as I said, the first thing I want to do is to show you the name box. So up here is the name box. You see it pops up there, name box. And typically it has the cell reference of the cell which is active, of the active cell. So one of the things that we can do is we can change the name of a domain to something else that makes sense and it is more recognizable than just the cell reference. So I'm going to go to where the value of R sub U is and go up to my name box and I'm going to type in R sub U. And you notice now, having hit enter, that it no longer gives the cell reference E18, but it now says RU. So I can refer to that cell simply by typing in RU, which is a little bit more obvious than if I had to type in E18 or otherwise press the cell reference. I'm now going to do the same thing for X sub E. Go up to the name box and call it X sub E. Okay, so we've set ourselves up to start the custom function. So the first thing you have to do, if it's not visible on your screen, is we need up here to have a tab for the developer tab. And you notice that it's not here. I've turned mine off so that I can show you how to go get it if you don't have it. It doesn't come active by default. So I'm going to go over to File, down to Options, and choose Customize Ribbon. And in the Customize Ribbon, if we go over here, it gives the main tabs. You'll notice that the developer tab is unchecked. So by checking it and pressing OK, the developer ribbon is going to pop up right up here. And that's going to give us access to the space that we need to do our functions. So in the developer tab, I'm going to go over and I'm going to open up the Visual Basic box, which I have over here. Okay, so now we're just going to create our function, and to do that, we want to do that in a module. So we're going to come over here and we're going to right-click, insert module, and that module will show up, opens up the module sheet, so it'll be available throughout the worksheet. And then we're going to start to create our function, and we also want to comment it. So we're going to start with a comment using our single quote, because coming back to this in a couple of years when we need to make some edits or otherwise figure what the heck we did when we did it, it helps to have a little bit of information beyond just the logic itself. So we're going to create a function to calculate resistance force R, which is a function of position x, and this is going to be an elastic plastic function. So that gives us a fair amount of information for which to do it. You see it colors itself green because it uses a color code. It recognizes that it's a comment. So we see right away when we look at it that it is a comment. Now we're going to identify what we're doing as a function. And we're going to give it its name, which will be r sub x. And in brackets behind it, we have to identify the variables that we're going to bring with us from the spreadsheet into the custom function. In this case, it will be the position x, the other two critical parameters to define it, which was r sub u and x sub e. And we hit return. It'll take care of all the spacing and everything else. And you notice that it leaves you now between the function and the end function commands, in which you can create the algorithm or the logic that defines the function. Now, because in this case we're doing a multi-domain function, we're going to have to use some level of, or some sort of Boolean logic. So now we need to build the logic. So we're going to use a simple if-else configuration. Tab over if space x is less than xe. Then we will do, just a minute, if x is less than xe, then hit return. And again, we'll tab in one more time. R sub x in this case will be equal to the slope, which is defined by ru divided by x sub e multiplied by our displacement x. And else, we need to give the constant r sub u. So we just put in our else, tab over r sub x is equal to r sub u. And at that point, we can end our if. If I haven't made any mistakes in typing this out, we should be able to then go use it. So I'm going to pop back over the spreadsheet. And this is the first place where we want to use it. We want to basically be able to call on it. So I'll go equals r sub x. And then we have to give it its variables. Remember, the first one that we set it up for was position, which we'll take from cell C24. I'll select that. Leave it as relative so we can copy it down later. And then the two key parameters, which we said were ru and x sub e. And because I've named them, I should be able to just type in their names, and you see that they've been highlighted on the spreadsheet. And when I hit equals, the custom function returns a value for that based on the parameters that it's received. So if I just drag and drop that down over the course of the domain, then I should see the values of the function. And you see I've already set up my graph up here to graph it. And we seem to be getting something that makes it, or looks like we've done it correctly. I guess the only thing that doesn't look pretty here is I don't have a 0, 0 start. So it might be a value to put in a 0, 0 start, but it's immaterial for the purposes of what we're trying to show here. So that's it. That's your custom functions, as well as using the named areas. And personally, I think this is one of the features of Excel that I use the most in making managing complicated scenarios that have Boolean requirements and everything else without a lot of personal intervention. I let the logic do the intervention for me. So I hope you find it very helpful. Thank you.